All right. Well, good afternoon, everyone. I was looking at the participants list, and it's a virtual who's who, I have to tell you. So thanks everybody for joining. I just caught the tail end the last few minutes of Duncan's Q&A, and it might be tough to follow up VR, but hopefully folks are excited about vSphere 7. I know we are. It's a rather sizable release, and I don't have enough time to do it justice this morning. Well, I shouldn't say that. I don't have enough time to go as deep as I'd like to go, but we'll get through it, give you the overview, and then we've got a bunch of great resources that you guys can deep dive into after the session or at your leisure. So as mentioned, my name is Adam Eckerle. I work in the Cloud Platform Business Unit here at VMware. I run the vSphere technical marketing team, and you can find me on Twitter at X79. So just I'll give you a brief overview of vSphere 7, but I really want to kind of focus on talking about the features. I'll talk a little bit about vSphere with Kubernetes. It's an important part of the release, but it's by no means all of the release. So some of you on the call may be interested in Kubernetes, and some of you may, well, we're not quite ready for that, or you're just kind of exploring. And so I don't want to spend the whole hour or so, or 45 minutes on Kubernetes. There's a bunch of stuff within core vSphere that we'll go into, and then I've got some links at the end. So talking about vSphere 7 being a large release, I'm not trying to embellish here. It really is a substantial release. In fact, in some of our marketing materials even, you'll see that folks will call this the biggest release in a decade. And there's a lot of good, valid reasons for that. As I mentioned, vSphere with Kubernetes is a big part of this release. A paradigm shift in how we're managing infrastructure for containers and VMs together, right? So we'll talk more about things like namespaces and how we're actually doing and bringing these things together, bringing things like DevOps and SREs together with our vSphere admins. So lots of cool stuff there that we'll touch on. Oops, one too many clicks. Next is, around vSphere Lifecycle in general, but specifically VLCM or vSphere Lifecycle Manager. Moving to a more desired state configuration model, right? Not this, we've got things like host profiles and auto deploy that help us do things like stateless configs, but it's kind of like a set and forget model where, we set it and then we forget to check it or don't need to check it, or, well, we always need to check it, but there's no sort of ongoing process, unless you count manual process, to make sure that whatever we've defined our state to be, that the hosts continue without configuration drift, without other administrators changing things and whatnot. So VLCM brings not only that desired state configuration model, but the ability to manage the hosts from hardware, firmware, drivers to ESX. So lots of cool things going on there. And then we also have DRS, which, between DRS and vMotion, which I'll talk about in a minute, these are technologies that have been around for quite a while. They're really cool technologies, but, over the years, these are technologies that sometimes we take for granted a little bit. And it's nice and it's really cool to see that we've taken these longstanding technologies and actually made them even more cool by some of the things that we're doing. Assignable hardware, scalable shares, that really allow DRS to, sort of go to the next level in terms of being able to balance workloads. Next, we've got assignable hardware. This is a framework that actually DRS can use, and also vSphere HA. But assignable hardware is just about providing visibility to specialized hardware that's in the VMs and allowing that visibility to features like DRS and HA. So that they can make more intelligent decisions. Typically, or up until vSphere 7, you've had to make some, I would say, significant trade-offs between adding a piece of specialized hardware like a GPU or maybe some other PCIe device that you're exposing through DirectPath IO. When you did that, you had to sacrifice typically some functionality. DRS would not be able to move it around. If you had an HA event, a host failure, something like that, vSphere HA may not be able to restart that VM on another host. So assignable hardware is all about bringing more intelligence to features like DRS and HA. Next, I mentioned vMotion. This is super important because vMotion is amazing, and I continue to hear stories even in 2020 of people seeing their first vMotion and it kind of blowing their mind. So it's really interesting to see vMotion kind of get tore down and rebuilt is maybe not the right word, but refactored is good, I think, in terms of breaking down the process. Under the covers, vMotion, I would say you could probably at a high level break vMotion down to like 6 steps. And a few of those steps we've really focused in on and took a look at what would be precluding a workload from utilizing a feature like vMotion. High I/O workloads, large workloads with large memory footprints, because there's a memory copy involved, and a stun time. So we've taken a look at those things and we've drastically improved a few of those pieces of the process, which has resulted in vMotion not only being able to service more workloads, but to be able to do it more reliably and more efficiently. And then last but certainly not least, at least at a high level as part of this release, we've talked about security since vSphere 6.5. So I feel a little bit like a broken record talking about security within a vSphere release, but we've continued to focus here because customers have asked us to, and we're continuing to not only simplify things that already exist, but add new functionality. And then, if you look a little bit down the road, things like our Carbon Black acquisition and how we're going to integrate that into the vSphere platform going forward. So we'll get into all of these different areas, throughout the slides. And these are just sort of the high-level buckets that we've placed a lot of the big features into. But there's, in fact, I have this mind map. Our team has, and Niels Haggart created it. But if you go to vSpherecentral.vmware.com, you'll see a vSphere 7 mind map that's got a lot of the different feature areas. That's a more complete view of the release, and you can just kind of see as an eye chart and a mind map that there's a lot of stuff going on here. So let me talk briefly about vSphere with Kubernetes for those that are interested. One of the challenges that we're trying to solve here is that modern applications are not just your typical 3-tiered app, right? They're not a web front end and a database backend wrapped around an application layer, right? Modern applications are, microservices, serverless. They're built on container platforms, and they use container orchestration platforms like Kubernetes or perhaps others. And we kind of saw the industry coalescing, so to speak, around Kubernetes. So that's the direction that we took. And this has been in the works for a number of years, actually. But with these new modern applications, there wasn't really a way to manage existing traditional enterprise applications and containers on a single platform with a single tool set. Developers and DevOps and SREs, they needed a certain set of tools. They wanted orchestration platforms like Kubernetes, and that required sort of a silo of IT to service those particular, service their side of the business. And then you had, sort of traditional IT, if you will, that had all the infrastructure that we know and love. At least I'm assuming in this community, that's the infrastructure we know and love. So how do we? Let me phrase it differently. So the challenge that we're really trying to solve is we have these two distinct, sort of customers, if you will, that we really wanted to bring together on a single platform. And it's not just about layering Kubernetes on top of vSphere, right? We wanted to have a value add solution that's integrated into the platform. That's not just a bolt on. So I'll talk about here in a minute exactly what that means. And the way that we're delivering this idea of a single platform for everybody is through VMware Cloud Foundation. This is the way that we can set customers up for success by having that common platform of the virtualized infrastructure with things like Kubernetes orchestration, with a common platform that extends to public cloud if you need it, right? Because our whether it's public cloud or through our VCPP partners who are providing clouds to their customers. It's a common foundation, right? Regardless of where your workloads are running. So that's why initially out of the gate, you see vSphere with Kubernetes as part of VMware Cloud Foundation, right? Plus, the Kubernetes piece leverages NSX for networking, which I know from seeing the participant list, some of you are probably are NSX experts, but let's put our customer hat back on who may not be NSX experts, who may not even own NSX, right? Getting that configured, especially with the move to NSXT, it can be complicated, right? It takes some thought and design into it. And so by being able to automate those, especially the networking component through VMware Cloud Foundation, we really feel that that's the way we're setting our customers up for success. And so that's why one of the big reasons why we see vSphere with Kubernetes delivered as part of Cloud Foundation. And so we have several different services. If we kind of peel back the curtain a little bit, there's really two ways to run Kubernetes within Cloud Foundation or within vSphere. One way is through Tanzu. We really think that Tanzu Kubernetes Grid is going to be the primary way. That's where folks are going to start, right? It's TKG, Tanzu Kubernetes Grid, is fully conformant Kubernetes, fully conformant upstream Kubernetes. And so essentially, this is using the new architecture that we've built into vSphere and running that fully conformant Kubernetes platform within VMware Cloud Foundation. It gives developers the same Kubernetes interface that they know and prefer, and we're bringing that inside the vSphere platform. Now, if there are customers that maybe don't have a Kubernetes footprint today, or they have a use case where they want a better security isolation model, they want an isolation model that's more akin to virtual machines rather than containers where there's not such great isolation today, and or I should say they want a little bit more performance out of their Kubernetes infrastructure. Then they can look at the vSphere pod service. This is the vSphere pod service is new. It's the piece that is built into ESXi and vSphere. And that's why, because it's in kernel and built in, that's why we're able to deliver a little bit better of an isolation model, as well as a little bit better performance. Now, you sacrifice being fully Kubernetes upstream conformant. So if conformancy is important, then TKG is where customers should be. If it's not important and they want those features that vSphere pod service brings, then they should go that direction. So one of the ways that vSphere admins, and I think more broadly this our ecosystem will benefit from Kubernetes on vSphere or vSphere with Kubernetes is through namespaces. Namespaces is a brand new construct. Let me just animate this. That allows us to basically take a pool of resources and wrap some policies around it, right? So namespaces are backed by resource pools, as the slides show. And then we can create some permissions policies, user access. It uses SPVM, so we can actually tag different types of storage and data stores and say, these data stores are allowed to be used by this namespace. And so essentially, you could kind of think about namespaces as VApps that are just much more robust and functional. So let me kind of articulate this a little bit differently. If you're a vSphere admin and you've got a developer coming to you saying, hey, I need to run Kubernetes to develop and deploy this new application that we're building. If you're running vSphere with Kubernetes on Cloud Foundation, you can say, hey, no problem, give me 5 minutes. You create a namespace, you give it a set of resources, right? You assign it a resource pool or create a resource pool for that namespace. You give that user access, or maybe they have a group of developers, so you provide it access to an Active Directory group instead. And then you attach a SPBM policy, and then you hand over a link to that namespace to that developer or group of developers, and boom, they access vCenter and have access only to that namespace. They can do just what you imagine. They can build up as much infrastructure as they want and leverage Kubernetes to do that. They don't even need to hit vCenter, right?
Right.
They can
So
they can use their kubectl command and a YAML file to deploy a complete Kubernetes application. Sorry, somebody's not muted. And it's as simple as that, right? They don't need to log into the vSphere client. They don't need to access the UI. They can just use the Kubernetes APIs that they already know and deploy their application. And it's all done within the sandbox of the namespace. So namespaces today with vSphere 7 are really interesting and an important construct here. But where I think we're going to see this go is the pie in the sky of being able to manage virtual machines and containers all in a single namespace or in across namespaces. So today we have this VM service that we're working on that is going to bring those two things together. So today namespaces are essentially container only or Kubernetes only, but we'll likely see in the future this VM service or something like it that will allow us to manage and deploy virtual machines via YAML file even. So the possibilities are pretty exciting. So I think I spent more time than I wanted to on Kubernetes. So let's dig into some of the core components of the vSphere 7 release. And first is Lifecycle. So if we can kind of break lifecycle management down into a few areas. One is with vCenter Server. So again, I kind of mentioned earlier about vSphere Lifecycle Manager, which is the next bullet, being in this desired state model. vCenter Server Profiles is taking us down that same path, right? Customers need a way to manage multiple vCenters, to deploy multiple vCenters in a consistent way, and to, on an ongoing basis, ensure that vCenter server is running, or to minimize configuration drift or to eliminate configuration drift. So vCenter Server Profiles brings that to the table. And then we've got Lifecycle Manager, which again, part of it is the desired state configuration model, where we create a cluster image. So we're creating this sort of set of policies at the cluster level and applying that to the cluster. And then, on an ongoing basis, we're checking that image for configuration drift and for issues and giving us automated capabilities to remediate those configuration drift issues. So more exciting stuff. And really, this is just the beginning for Lifecycle Manager. Well, I'll go into how it relates to VUM in a minute. And then third is Update Planner. Update Planner is a way to bring some confidence to vSphere admins when it comes to upgrades, right? I'm not going to sugarcoat it. Upgrades are complicated, right? When we're talking about vSphere. vSphere is sort of a nucleus when it comes to virtual infrastructure. And there's a lot of dependencies on vSphere, and just within vSphere itself, we've had architecture changes with PSCs and things, and it can just be difficult to understand how to get from point A to point B. There's multiple components involved, and so Update Planner is a way to arm vSphere admins with a way to assess what's in the environment, what versions is everything, what happens if I upgrade my vCenter server to this version? Is it going to break other things? And so one of the things that makes these lifecycle components better is a recommendation engine. And this is something that, I think that the vSAN team originally built, and now it's sort of bleeding out into other areas, and we're able to take advantage of it outside of vSAN, which is really cool. So, well, let's get more into these. So vCenter server profiles, as I mentioned, is interesting in that, we're able to deploy a vCenter server, take that configuration, and then apply it to additional vCenter servers. Or if let's say you're a partner and you have a practice around delivery, right? So one of the advantages here is that now, you probably want to deploy vCenter servers for your customers in some sort of standardized way. So wouldn't it be really cool if I could, take a JSON file and just change a few fields, name, IP address, things like that, and have a very consistent manner of deploying vCenter servers across a whole bunch of different customers, and just tweak the things that are needed based on an individual customer's requirements. And then you have a way to, on an ongoing basis, maybe you have a managed services practice, and you could write a tool to use these RESTful APIs to make sure that the vCenter servers across all of your customers are within the spec that you originally deployed it, and you have a JSON file with how it was deployed, so you have documentation of how the vCenter server was deployed. So both as a customer and a partner, vCenter server profiles is a pretty neat improvement. Now, I want to be clear that when we're talking about the state of vCenter server and what is in scope for vCenter server profiles, it is the configuration of the vCenter server appliance. So things like IP, DNS, NTP, administrator password expiration policies. Those are basically, if you log into VAMI, anything within the VAMI is what's in scope here. We're not talking about distributed switch configurations. We're not talking about VM and folder organization or resource pools or anything that's really part of the vSphere infrastructure. We're really just talking about the vCenter server appliance itself. And that's why, it would be easy to adapt this kind of process to deploying vCenter servers across, a whole bunch of different organizations. So this is going to be exciting, and to see what our customers and partners build with these APIs. Next, we've got vSphere Lifecycle Manager. This is probably the biggest piece of the lifecycle story within vSphere 7. I've mentioned a few times about the declarative state model or desired state configuration. So I'll kind of skip over that and focus on things that I haven't mentioned yet. Full stack firmware updates. If you think about hosts, right, you have to, as a vSphere admin, you have to manage not only the version of ESXi that's running on a host, but what drivers are running and what version they're running, what version of firmware is running on the host. So full stack firmware upgrades is a component of Lifecycle Manager that allows us to set those things as a policy, as a cluster image, which I'll show in a second, and apply that to a cluster as a whole, and then monitor that cluster for configuration drift. So that's great for not only standing up a new cluster, but also for scaling out, being able to add a new host and just have it inherit that cluster image that is a ESXi version, drivers, and firmware. We also integrate with today with Dell and HPE as far as firmware management. So if you're running OpenView or OpenManage or HPE OneView, those are tools that you will have right from day zero when you upgrade to vSphere 7 to help manage firmware drivers within your hosts. We are definitely working with other OEM partners to expand that portfolio. Next, something that's not new but also benefits from this and kind of brings it together is the Cluster Quick Start workflow. Whether you're a vSAN customer or not, Cluster Quick Start is a great way to bootstrap clusters. So not only is it VLCM can manage the full stack firmware, but Cluster Quick Start then wraps around Distributed switches, you basically define a distributed switch and say, I want these hosts that I'm building this cluster with to attach, these uplinks, these VM kernel ports with these IP addresses. And you can basically take a lot of the things that you would normally do to instantiate a vSphere cluster and do that once up front, and then use Cluster Quick Start to then add in hosts to instantiate that cluster. And it also works with scale out, right? So if we're going to add hosts to a cluster after the fact, Cluster Quick Start is another way to do that. Again, from a configuration perspective, right? Full stack firmware updates is managing the clusters from a cluster image perspective. Right, and I mentioned the recommendation engine before, but I think it bears repeating, right? This is a super important piece of this workflow in that, we're not just providing, hey, this driver version or these 10 driver versions and these 10 firmware versions are compatible with your system, right? We're actually using the recommendation engine to say, well, yeah, sure, here's a range of stuff that will work, but here's actually what VMware and, if you're, running Dell infrastructure, here's what VMware and Dell recommend for that system, or here's what VMware and HPE recommend for that system based on the HCL and the configuration guides. So the recommendation engine is really powerful and is going to be an important piece to leverage as you start working with Lifecycle Manager. So here's kind of, just a visual representation of the cluster image. Again, we've got the ESXi version, we've got the firmware and drivers, and then we've got the vendor add-ons. So if you think about, up till now, you've gone to either VMware.com or maybe you've gone to your server OEM, Dell or HPE or a number of others, and they have a customized ESXi ISO. You go and you download that ISO because it's got custom VIBs. It's got things that are important for that make and model of hardware that you're using. So what the vendor add-ons piece is in Lifecycle Manager is the ability to bundle all of those things into essentially your own image, right? You don't have to go download or wait for the OEM customized image. They can publish a zip file of the things that would normally go on that image, and you can download it and you can integrate it right into Lifecycle Manager. So it's part of the cluster image. So this is going to be really powerful. And again, this is a first step, and we're going to see this get more and more powerful as time goes on. With Update Planner, again, things are complicated as far as upgrades go. I wish they weren't. In fact, we've spent a lot of time trying to make it better from a usability perspective, from a taking out complexity. But at the end of the day, we know and understand that customers still can sometimes struggle with it, and sometimes just look at it as it's so much work that I'm just going to stay where I'm at. And we don't want that for a number of reasons. If Bob Plankers were here, he would say that you have to patch. Patching is part of good security hygiene, and a number of other reasons to stay up to date. But we understand it's tough. So Update Planner is a tool that we're delivering to help with that. It's all built into the vSphere client, which is nice. So you don't have multiple interfaces to work with, and it's not a separate tool. The nice thing is the what-if workflows, or one of the nice things is the what-if workflows. Being able to simulate, as I mentioned before, like, well, what if I do upgrade this component? How is it going to affect and interact? Am I going to put myself in a situation where I've upgraded vCenter server, but oh look, I've broken my SRM and NSX deployments. So this is a way to really assess and plan, and ultimately, if I can say this in my own words, it's really about trying to give folks confidence that they can get from point A to point B. They can do the upgrade and not run into or put themselves in a predicament. So again, really excited about this piece, and hopefully it helps customers grease the wheels and to be able to keep those upgrades going so that they can stay more up to date on vSphere. So a couple things to mention, and one is, simplified architecture. This is, I can't tell you the number of times I've talked to customers that have been frustrated and put off by the number of architecture choices. Folks doing things like putting external PSCs behind load balancers, not because they had a requirement to do so, but because they thought that that was the way to be more enterprise-like. And it led to some really tough challenges, not only from a lifecycle perspective, but just, reliability with PSC replication. And now you've got a load balancer in the mix, which may be managed by a different team. And so, I think, more than a year ago, we kind of announced that we're moving away from external PSC. And so with vSphere 7, not only is external PSC gone away, but there's no more vCenter server for Windows. So everything is a single platform. I'm not going to say that somebody doesn't have a valid use case for an external PSC, but really the PSC should just be thought of as just another service running on vCenter server. You don't have to make complicated decisions and trade-offs around using external or embedded. We really, since the original release of vSphere 6.7, we started talking about trying to get customers to embedded only. And then you started seeing us release tools to help with that, convert from external to embedded, and the converge tool, as we call it. And so now with vSphere 7, you really don't even have the choice. And the other nice thing is, not only do you need to go this direction, but it's built into the upgrade. So you don't have to use a separate tool or converge prior to upgrading or anything like that. The installer or the upgrade UI will detect that, hey, you're running an external PSC, so I'm just going to go ahead and converge that for you as part of the upgrade process. So just having this all as one nice single unified workflow. If you're going from sort of this complicated architecture in vSphere 6.5 or 6.7, you've just got one simple workflow to get you to here. So excited to see this as part of the vSphere upgrade workflow. A couple of things too that I think are important is scalability. For those customers that just continue to help us push the envelope, we do have some enhancements there. Namely, we've got a pretty sizable improvement, 3x improvement in the number of hosts and the number of powered on VMs you can have within a vSphere SSO domain. So if you've got 15 vCenters running, you can now get up to 150,000 powered on VMs. So pretty significant, 15,000 hosts. We also have a little bit of a minor update, I would say, on latency numbers. This is something that we, was really kind of untested, and there wasn't a lot of focus on it prior to vSphere 6.7. vSphere 6.7, we started investing here, doing more testing, trying to give our customers better guidance than sort of, 500 milliseconds of latency is bad, or 100 milliseconds is what you should stay within. So we kind of had a little bit of a best practice. You probably heard a lot of vSphere folks talk about. But now with additional testing, with simplifying the architecture, with some additional enhancements to Photon OS and vCenter Server, we're able to extend that latency a little bit to 150. So again, we're probably talking about being able to have vCenters, maybe across the Atlantic, maybe across a continent, but certainly, 150 milliseconds is not enough to get, to a global SSO domain. But I can tell you that it is something that we're working on. It's something that we hear from customers, that they want this latency restriction much higher, so that they can have a single global SSO domain if they choose. So to sum it up a different way, we're working on it. We've got a modest improvement here in vSphere 7. Hopefully we'll see these latency numbers and even all the scalability numbers continue to grow. So let's talk about security. One of the things that you've probably heard me talk about at some point in time, and now that torch has been passed on to Bob Plankers, is certificate management. So it's good to see in vSphere 7 some pretty significant improvements here. If you look at where things were with vSphere 6x, 6.5, and 6.7, we did make some improvements with Certificate Manager, but still, there's just, as you can see from the GIF, there's just a lot of certificates to manage. This is a single vCenter, right? There's the machine TLS cert, there's the solution user certificates, there's the VMCA certificates. So there's a lot going on here. It's a lot to manage. And so with vSphere 7, we've simplified this dramatically. Now we really just need to work with the machine certificate or the TLS cert, and then the VMCA root certificate that's part of the PSC services. So just this in and of itself, I would say is a pretty significant win, reducing the amount of things you have to manage. But then we also, wrapped APIs around it so that we finally can get to that point where we can automate certificate management using RESTful APIs. I know over the years, there's been some great people in the community that have built certificate management tools using what little APIs were available and some creative scripting. And I think we wore them out because every time we released a patch, it broke their tools. And it was really frustrating, not only for them to build these tools only to have them get broken, but also for our customers, right, to not have a real great way to manage certificates. So I'm excited to at least offer the APIs that we've been wanting for a long time now in vSphere 7. So we can wrap a lot of automation around certificate management. Next is identity federation. Again, something that's really exciting. Let's face it, there was really no scalable way for vCenter server to become extensible with every type of authentication and authorization mechanism in the ecosystem. There's just a ton. You've seen sort of the challenge manifest in that we've only been able to support a single multi-factor authentication solution up till now. With vSphere 7, out of the box, we support integration with Active Directory Federation Services, ADFS, such that ADFS can talk to a lot of MFA solutions. If you can integrate vCenter with something like ADFS, then you're sort of bringing in all this additional capabilities to vCenter server without having to make a bunch of code changes and add code to vCenter server itself. So with vSphere 7, ADFS integration is the way that we're providing that capability to integrate into these other MFA solutions. But again, this is just the start. We do have plans to integrate with additional authentication and authorization providers, but this initial integration with ADFS is important for those that need that already are using ADFS, but it also provides you a roadmap with being able to support additional MFA providers and tools today, but then possibly having more direct integrations with those other tools down the road. And I think it's important. I hear Bob talk about this a lot because I think people see something like this and they can get kind of scared, like, oh crap, if I go to vSphere 7, I have to make sure ADFS is up and running and configured, and that's a lot more work just to upgrade to vSphere 7. And that's not the case. We still support the traditional, I'll call them traditional authentication mechanisms, LDAP, LDAP-S, integrated Windows authentication. We want folks to move away from those, but you don't need to do that in vSphere 7. They're still fully supported. So you can upgrade without having to do the ADFS stuff for now. And then later on down the road, we'll probably deprecate those traditional authentication mechanisms, and identity federation is going to be the way forward. But for now, you're still okay there's still some overlap. This is just a visual representation of what the user experience is. It just basically shows that we've got this federated authentication mechanism behind the scenes. We log in with our Active Directory credentials in this case, and that authentication is done with ADFS, and it allows us to control what we're authorized to use. That's the authorization piece as part of this integration. So another big piece is trust authority. And in order to talk about trust authority, I kind of want to set the stage with where we came from. We had cool and interesting technology in previous versions of vSphere, VM encryption for one, which required a key manager, right? But that kind of introduced a little bit of a chicken and the egg scenario. Because vCenter Server did all of the work as far as interfacing with the key manager and storing keys and those kinds of things, you couldn't encrypt vCenter Server itself. And so that kind of had the challenge of, well, everything else in my environment is encrypted, but sort of the brains of the operation couldn't be encrypted unless it was encrypted by some other vCenter elsewhere in the stack. So there was some issues there, or some challenges that we needed to solve. So in vSphere 7, we introduced trust authority, which basically allows us to take a set of hosts and make them our trusted hosts. And these trusted hosts do, sort of offload those operations, those core operations or key operations from vCenter Server and allow us to, encrypt vCenter Server for one, but really just allow a more efficient and robust process for managing encryption within the environment. This also means that TPM chips are really important. TPM chips are very affordable. They're probably, forgive me for using US dollars, but they're probably like 30 or 40 US dollars, which hopefully if I did my pound conversion, you would see that they're pretty cheap in the grand scheme of things, right? Servers cost thousands of pounds. We're talking about tens of pounds for TPM chips. So we really should just be, when you order servers from your server vendor or through a partner or whoever, just buy that, make sure the TPM chips are in there, because whether you use them or not today, it's going to be much easier for you to adopt something like trust authority, later on down the road. I also do want to make it clear that these trusted hosts do not have to be, dedicated to this. It's not like, okay, I have 10 hosts, now I have to buy 3 extra to take advantage of trust authority. That's not the case. We definitely recommend as a best practice that, these trusted hosts are not servicing, your production workloads. But if they're part of a management cluster, those hosts would be great candidates for something like this. Some customers may want to dedicate smaller hosts to something like this, but I really doubt it. So the idea is that, from the picture, it kind of makes you think that these have to be dedicated, doing nothing else, and that's not what we want. That's not practical for customers or cost effective even. So don't think that these have to be dedicated. They can do other things other than trust authority. Next, I'll go over this rather quickly because we're running out of time. VSGX is an Intel feature, let's say, that we're exposing. It's a way to provide applications a place to store secure data. Basically what happens is with hardware compatibility 17, which is new to vSphere 7, we can add a VSGX hardware device to a VM, and that gets exposed to the whatever application is running within the guest operating system, and provides the interface for that application to store data within the secure enclave. AMD has something similar, but it's a completely different mechanism and something that we'll support later on down the road. I mentioned that it's a hardware device. It's just a quick screenshot. And next, I want to just in the few minutes, if I can go just a few minutes over, and maybe take some questions. One of the important things that make...
I was going to say, we've got an hour's break after this, right? So, I mean, if you've got the time, I'm pretty sure we're all more than happy to hang around and discuss.
Okay, cool. All right, I'll try not to go too far over because I don't want to go too far into break, but thank you. So assignable hardware is, as I mentioned, it's really a framework that enables intelligence for other features. Mainly in this release, we're talking about DRS and vSphere HA. It really allows us to, or allows DRS and HA to understand what hardware is being exposed to a virtual machine. And by hardware, I really mean specialized hardware, like PCIe devices, like GPUs, that we would normally expose through things like dynamic direct path IO. So essentially, this gives those features the intelligence to do, like for DRS, to do initial placement of a workload, because it understands what hosts have the available hardware and what the requirements of that workload are. So it can say, okay, not only is, I've got 3 hosts that I could power this VM on, which one is the best from a DRS perspective, right? Prior, DRS couldn't make that choice. You couldn't point it at a cluster and have DRS tell you which host was best. You had to manually choose a host that you knew had the hardware capabilities that VM required. So that's a nice improvement. And then, as I mentioned earlier, hardware failure, right? vSphere HA can now restart that workload on a host that has that available hardware. So this is really cool and really kind of an under the covers piece of functionality, but it's important from the perspectives that I just outlined. From a DRS perspective, just quickly, there's a lot of great content. If I had more time, I'd spend a little bit more time here. But if you go out to our vSphere blog and the vSphere YouTube channel, you'll find Neil's doing some videos and some whiteboards on this topic. But if I can boil it down, as DRS prior to vSphere 7 was really about cluster happiness, right? Is the cluster balanced? And it would move workloads around in order to satisfy that construct. Is the cluster as a whole being efficient from a resource perspective? With vSphere 7, we're really more focused on the workloads themselves. Talk about VM happiness. So there's this DRS score, internally, or I've seen folks call this the VM happiness score. So we're really, instead of looking at the cluster, we're looking at the workloads themselves. And when DRS makes decisions, it's able to, do so and understand, when I move this VM from host A to host B, how is that going to affect the VM itself? Like, is the VM going to be in a better resource situation post move? And is its neighbors going to be better after this move? So the idea is that we're so much more focused on the workloads, and we're running the DRS algorithms more frequently, every minute as opposed to 5 minutes before. So this should result in a much better overall cluster utilization and much more workload happiness based on these changes. I'm going to pop into vMotion. So as I mentioned at the top, this is something that, if you can imagine that vMotion is like a six-step process. The middle of that process, where we do things like copy pages from host to host, where we stun the VM, at the very end of the process to make sure that no more writes go to the originating host and the writes start going over to the destination host. Those are the core parts of the vMotion process that we took a look at and said, okay, how can we make this even better? Because, if you have a database that's really high IO, or maybe, an SAP HANA deployment that, a lot of the database I/O is happening in memory, right? If you can think about an in-memory database, that primarily everything that's happening on that workload is happening in memory. How do we stun that for long enough to move a terabyte of memory from one host to another, where virtually, a majority or much of that memory space is dirty from the time we instantiated the vMotion, right? It's like this constant cycle of copying stuff and stunning, and copying stuff and stunning, and also doing it at from a small page perspective, right? So one of the things that we've done is we're using huge pages to copy the memory space. We're doing it at 1 gig chunks at a time, so much more efficient from that perspective. We're also there's memory tracing involved. So how do we map and keep track of the dirty pages, and how do we know what to copy and what not to copy? So we're making sure that we're only copying the pages that need to be copied, and we're also, instead of using all the CPU cores in the VM to keep track and do the page tracing, we're dedicating one core to do that. Because what happened is, when we used all the cores, we spread the tracing across all the cores, it would basically cause that VM to become saturated and resource starved. So it couldn't effectively, it might not effectively finish that vMotion operation, or be able to do those processes in a way that that stun time stayed small enough for it to move to the other host without causing some other issue, whether it's in the application or just for the vMotion itself to time out. So lots of under the hood improvements, and the result is that we, regardless of how much I/O is going on within the VM, how large of RAM allocation it has, vMotion should be able to effectively work on just about any type of workload. So if you're a customer that was running some of those workloads in production, that you just had to pin to certain hosts and disable vMotion because of long stun times, or it just didn't work, I would say that you can now test and try again with vSphere 7, because all these under the hood improvements should enable those types of workloads to take advantage of vMotion. And it also means that normal vMotions are probably going to be much more efficient as well with these improvements. So this is tech preview. When we talk about Bitfusion, it's not GA yet, but you'll probably hear us continue to talk about it until its eventual general availability. It's in beta right now, so if you talk to the right people or want to get involved in that, you may be able to. But this is super exciting in terms of taking the specialized set of hardware that is also probably pretty expensive, and to be able to expose it across a network. So if you think about the paradigm of having to have the specialized hardware and a certain set of hosts, and only workloads that are running on those specific hosts can take advantage of the functionality that's enabled by this hardware, whether it's AI ML, whether it's VDI, whether it's rendering farms, CAD workstations, whatever. You had a pretty defined set of guardrails that you had to live within. What Bitfusion does is enables these hardware accelerators to be accessed over the network, and so it unlocks a huge set of potential around what kind of workloads can take advantage, scheduling and efficiency of these workloads, being able to make sure that, hey, I just bought this expensive set of NVIDIA Tesla cards for my rendering farm, but I also want some data scientists to be able to access them periodically to do machine learning. The possibilities that this unlocks is really exciting. And so again, tech preview in beta today, and you'll see more over the next year. So just a few things to keep in mind. I'm not going to go through this, but I do like to show it, and then that way when I provide the deck afterwards, you can review this in more detail. But we put together a top 10 reasons to upgrade So if you're thinking about it, or if customers on the fence, this is a asset that you can provide or review yourselves to kind of make a decision. Obviously, I want everybody to upgrade. And if you're running on vSphere 6, hopefully this is not news, but it's end of general support as of beginning of March. So if you don't already have a plan to move away from vSphere 6, 6 months ago was a good time to think about it, but just wanted to remind everyone. And then here's some, the link at the bottom there, the vmw.re/vSphere 7, takes you to the vSphere blog, where we've put together in a single page basically all the blog posts related to vSphere 7 that we've released so far, and then that we're going to continue releasing. We add them there. It also has links to YouTube channels, to vSphere Academy, to our friends over on the vSAN team, if you're interested in what's new in vSAN 7, as well as Cloud Foundation 4. So it's a pretty good sort of single place to go to get links to everything you want to know about vSphere 7. So with that, 10 minutes over, definitely appreciate everyone sticking with me. And in fact, I'm not going anywhere. So if people have questions and want to stick around, feel free.
Thanks, Adam. That's really good. So yeah, I mean, guys, if you got questions, right now is a great time to take advantage of Adam's brain.
Looks like there was a lot of chat activity. I'm just gonna run through that, see if I can answer anything.
So I think, Adam, one of the questions that hasn't been answered in the chat was from Catherine, and it was around, can we automate the replace of certs on ESXi hosts as well? Because that's an ask from a lot of the large customers.
Yeah, so I would say we're not quite where we need to be in that regard. We're better off. The API allows us to do some of that functionality, I believe, but not. I think we can do like renewals, and if you're using the VMCA for ESXi certs, but I'd have to double check. I don't believe if you want to do full custom, where you're getting certs from external CA or from an enterprise CA in your environment, I don't think the APIs support doing things like generating a CSR from a host, submitting that CSR to a CA, and then I don't think all of that is automated. In fact, I'm pretty sure that it's not. But if you're using the VMCA that's built into vCenter Server, I believe the API can support doing things like renewing or replacing those certificates.
Okay, thanks for the clarification. So for my side, it's more around that last stage. So for example, if a customer has a VVD or a VCF deployment, then you can automate the creation of the CSR files and get the customer to give you all the certificates in one go. But then to replace them on the host, if they're using their own CA server, is a manual process, or has been traditionally. So I just wondered if we'd improved that, but sounds like it might not quite be there. So fingers crossed for the roadmap.
Yeah, and actually there's a slide that Bob Planker's put together that I didn't include for time, but I still think it's important to reiterate that we really want customers to leverage the CA infrastructure that we've built into the product. I know that some security admins will say, over my dead body, am I going to use the VMCA? But we think that is a good path forward, and that's why we kind of start there. But I think we will see some tooling changes in the future that aid those customers that want to do full custom. We think that we have a better solution. But thanks for the question, Catherine.
And then there's another question from Chris Bradshaw. Is there any out-of-the-box or well-documented way of connecting up with Azure AD rather than the usual on-prem ADFS?
I don't know the answer off the top of my head. I can't think of a reason why that wouldn't work, but I haven't set it up myself, and so I'll have to defer to Bob on that. We can probably get an answer. Let me see if I can copy this question out. Also, I don't know a whole lot about Azure AD, so there could definitely be some things that cause restrictions. But from a vSphere perspective, I don't think we care where the ADFS is living. But let me take a note, see if I can verify.
Okay, we've got any other questions?
So we've got Martin Isles. Can we run mixed 6.7 and 7.0 within an environment and vMotion between them?
So yes and no. We technically we don't. Our support statement is that we don't support mixed versions within the same environment. Mixed major versions, with 6.7 and 7.0 are major versions. We would only support them in times of, upgrade. So if you're in process to upgrading multiple vCenters, of course, there has to be some time where they interact with each other. But we say we don't support is if you're going to upgrade a vCenter, 1 weekend and you're going to wait 6 months to upgrade, the other one. That's not something we want customers to run in for an extended period of time. So that's part of it. Can you vMotion from a 6.7 host to a 7.0 host? Probably. There are probably some things that could prevent, are there processor differences? Are we using EVC properly? Those types of things. So there are definitely some check boxes you need to check, but you can probably make it so that you can vMotion between different host versions.
Okay, yeah, I asked because it's something we've had issues with in the past as we're looking to upgrade our environments and the whole, if we've got some ESXi hosts that don't support v7 because they're not on the HCL, then we're kind of, what do? We either split everything and then have to run 2 entirely separate clusters. And if the vMotion isn't, if the answer to can I vMotion from 6.7 to 7.0 isn't yes, that's going to give us big issues, because how do I upgrade the environment? How do I get all my applications across onto v7 if I can't, given that we're a 24/7 real-time operation, if I can't vMotion them across, I've got to start redeploying everything and then changing all the DNA and everything else. It just makes the upgrades really difficult.
Yeah, I mean, if you think in those terms, right, we've sort of always supported vMotioning between, because if you use VUM, for example, to do a rolling upgrade of a cluster, right, you put one host in maintenance mode, evacuate it, upgrade it, and then take it out of maintenance mode. If you're using DRS, it's gonna move workloads right back to that original host to make sure the cluster is balanced, even though it's at a newer version. So, the key, right, is vCenter server gets upgraded first, and then if you're just upgrading a cluster in place, then it's no problem at all, right? If you could vMotion before, you're going to be able to vMotion. If you're talking about, I'm standing up a new 7 infrastructure and I want to vMotion from my old infrastructure to this new, that's where things like EVC and networking and those kinds of things come in. And that's where I was kind of like, that's where my head was at. Definitely like the in-place upgrades, like you completely fine.
Yeah. Okay, thanks.
Also, I just want to shout out Duncan. Thanks for posting your blog on scalable shares. That's something that I probably should have mentioned, but just got short on time there towards the end. Just if read his blog, because he explains all about of what scalable shares brings to the table. And I'll explain it as we're probably, a lot of us are probably familiar with the pie paradox, where you take a resource pool, and let's say you create 3 resource pools, high, medium, and low, right? And you put all of your business critical applications where you want to guarantee resources and performance, you put them into the high, right? And there's bigger VMs, but maybe fewer of them in that resource pool. Majority of your workloads. Sorry, go ahead. Oh, maybe accidental unmute. And then majority of your workloads maybe go in the medium resource pool, and then some amount of VMs go in that low resource pool, right? And if you look at from a resource pool perspective, right, the high has the most resources allocated to it, and then the low has obviously the lowest set of resources allocated. But over time, right, if we add workloads, or maybe we add memory or CPU to a workload that's in the high bucket or high resource pool, right, we run into this problem where we never adjust the amount of shares across those 3 resource pools, right? So the amount of resources that are being consumed in the environment is not constant, right? And so the way that the resource pools interact with each other from a resource perspective is by sort of percentage of shares and or number of shares. And if we add workload or add resource consumption to a resource pool, we manually have to go in and adjust, how many shares each resource pool gets. Because what we'll find is, we always see that a line of business owners are like, well, my little rinky-dink application, it's business critical, right? It has to go in the high resource pool. And so we find that we put more and more VMs into that high resource pool, and that resource pool becomes starved because it can't expand. It can't take more shares than we've allocated to it. And so then we find the low resource pool actually is more performant, or workloads in that low resource pool are more performant because of how the shares are unbalanced across the resource pool. So scalable shares is a way to help solve that challenge, among other things, right? We want to make sure that we also are able to apply this to namespaces, right? Because namespaces are also built on top of resource pools. So scalable shares it really wasn't built to solve the paradox pie problem. That was kind of a byproduct, I think. But with namespaces built on resource pools, scalable shares is something that really enables us to have and create and spin up these namespaces and spin down, and not have to do a whole bunch of manual reallocation of resources constantly in the resource pools that are backing the namespaces. So I think that's Duncan's blog post I think goes into all of that in much greater detail, but that was kind of the gist of it, I think, in my words. Dean talks about PTP, or Precision Time Protocol. That's certainly, there are a number of features I didn't mention, right? PTP is one of them. Multi-NIC vCenter is another one. So, you can actually add multiple NICs now to the vCenter server appliance, which is something we haven't supported before, with the exception of vCenter HA. Right? vCenter HA requires a second NIC, but outside of that, you can add up to four NICs to vCenter. So that's another feature.
Adam, do you know if it's on the roadmap to allow QoS for those NICs in the future, for things like when a backup provider is speaking or directing traffic through the vCenter?
Well, even if I did know, I don't think I could say, but that is not the first time we've heard that challenge. So I think it's reasonable to think that, we'll address that at some point. I couldn't tell you when, but that's definitely, one of the primary reasons that we even started down the multi-NIC path to begin with was for exactly that. Customers needing vCenter to talk to a dedicated backup network. And so I think it's reasonable to suggest that that's something that we could address at some point in the future.
Cool. I just kind of had a general question, really, but in terms of how you develop vSphere, is there something you could tell us about the way you do testing of new vSphere builds? Do you do, I imagine, a whole bunch of nested stuff, or do you do this on physical kit, and what that kind of looks like as you sort of go from very, very early stage, I guess, alphas all the way through to betas and GA?
Yeah, so there's a number of different workflows that occur. Obviously, we do a lot of different testing. So we have lots of automated testing. We have QE that does, QE are the folks that, they get involved later in the process, and they're the ones that are doing this in more of a physical way and testing things more thoroughly. We certainly have a whole bunch of automated testing that happens every time a new build is created through our build system. It goes through a number of different smoke tests and things just to ensure that the main line of code is stable. So something that has happened at VMware in general, not way above vSphere, is the way that we develop our software. We're definitely moving or have moved to more agile models. We used to develop, within, I can speak more accurately to within vSphere because that's what I'm most familiar with, but I think this applies to the company in general. vSphere used to be developed in a way that was, we had a different set of code for, or different branches, I should say, different branches for, different update versions and different patch versions. And they were kind of forked and created very early on in the process. Whereas now we've consolidated everything and we have one main line of code. And then, as late as possible in the development cycle, we're forking that code off the main line for that specific release. And so a lot of this automated and manual build testing is done on the main line of code. And that ensures that when we branch off to do like an update release or a patch, that we're inheriting all the testing that has already been done previously, and that drastically reduces the scope of what's required to be tested, or the testing matrix for patch and update releases. So it's made things much more efficient. It's made things much more reliable. I'm sure that our release management folks and even GSS folks could probably talk about impacts to things like GSS and SR volume, as well as efforts and resourcing within engineering. So there's probably way more to it than that, but that's kind of the simplified view of what I know.
Cool, thanks. Okay, any other folks got questions for Adam? I appreciate it's quite early where you are.
That's okay.
We're pretty much midday here, so thanks very much for coming along. Do we got any kind of closing questions before we let Adam go off and have the rest of his day? Okay, that's great. So Adam, look, really appreciate you coming along and it obviously being so early in your day there. So thanks very much. That was really interesting.
All right, great.
Great, cool.
Thanks all. Cheers.
Thanks.